Okay, we're live. Hello, welcome back everyone to the workshop series of Huntathon by Archway. Super excited to kick off yet another workshop, and this is going to be the last one for the workshop series. We've wrapped off 11 workshops for now, and that is, for you to make for your building journey to be easier, for you to have a better navigation through all the developer docs, all the tech that's going to be useful in the journey in your project. But super excited to have Adrian with us today. Um, Adrian, welcome to the workshop and thank you for the time. Just to
Thanks, sir.
recap, just to recap, for the hackathon, we have four major tracks. The first one is DeFi Warriors, then Mystic Degen, NFT Explorer, and mobile crafters. And all of these have a price pool of 25K each, which gets us to a total of 100K price pool. Um, but yeah, we have 7 day left till the submission window closes. So I can see a lot of projects flowing, have submitted, and a lot of projects still flowing in. Very excited for all of you to build and see what everyone has built. But without taking a lot of time, Adrian is going to talk about building secure and efficient smart contracts, and I'll give it to him. But before getting on the workshop content, Adrian, do you have any opening thoughts to share with the devs building for this hackathon?
Thanks, Mishka. Yes, so we do have an office hour tomorrow within our the Archway Discord channel. I think it would be good for a lot of devs to join that session. We'll also have the members from the Andromeda team uh, taking part in that session as well. So what we're trying to do, we're trying to make it easier for devs to get help with their submissions and the dApps that they're working on. So yes, if you can join that, that would be great. But we're looking forward to seeing great dApps in each track, and yeah, hopefully we'll see some unique stuff created by the community. So looking forward to that.
Perfect. Yeah, thanks a lot, Adrian. Let's go and get on the workshop. For everyone watching, if anytime you have questions, feel free to drop it in the chat and we'll take it up at the end. Thank you.
Okay, everyone, thanks for joining. So this particular workshop, what I wanted to do was to like go through some of the things that I've learned over the years in terms of building smart contracts. It's a bit different than building in the Web 2 space. So especially I know a lot of you developers are coming from the Web 2 space. So I just want to give, and also coming from other ecosystems, for example, Ethereum, which is a popular one. Just want to give some insight into the various issues that you might come upon while building smart contracts on Archway. So, one of the if you're coming from the Ethereum ecosystem, one thing you would know is that contracts by design are not upgradable, and that's a challenge in a number of ways. So yes, immutability can be a plus in that it gives you confidence that whatever the contract was in the beginning, that will be the same throughout. But if you've been in the software development game for a while, you'll know that like bugs are very common within the software development landscape. And so there needs to be a way for you to fix those bugs. And the thing with immutable contracts is that they're not upgradable. So if you have an immutable contract and you've not implemented any mechanism to upgrade those contracts, then what you'd have to do, you'd have to close that contract and start a new. So you generate a new contract address, which not might not be um, the best way to go, because then all the front end apps or all bots and other services that utilize a particular contract will need to know that they need to upgrade um, or update the contract address, and also any entry points that might exist within that contract if there are new entry points. So um, yeah, and especially if you're creating new features or you need to add new features, which most software systems will do over time, you definitely can't do that if you are not able to upgrade your contracts. So there are upsides, but there are a lot of downsides to having immutable contracts. And as I said before, within the Ethereum landscape, all contracts are immutable by design. But developers have found ways to go around this, and the proxy design pattern is one of those ways. And you could still implement such a solution within the Archway ecosystem, but we have something that's a lot better, because by default, Archway contracts are upgradable. So and this is controlled by the dev as well. So when you initiate or instantiate a new contract, you have the option of setting an admin field with an address that you would own, and only that address can execute what we call a migration. And a migration is simply moving from this old contract to a new and improved contract. And that allows you to move or to upgrade your code. And it allows also to upgrade the state as well if you need to. But if that's not a requirement and you just need to upgrade the code base, that would be just change. So essentially you're changing the code ID from the contract that's now live to a new code ID. But you're still utilizing this exact same contract address. And I think that's very, very useful. So how you go about doing this? The CW2 module that would be a dependency within your contract allows for setting a contract version. So within every contract, within the instantiate function, you would see this usually where you call this contract version function. The contract name would be, it's picking from the JSON file or the TOML file used for the contract, and it's picking the name from that file. And the contract version is the version number within that TOML file or configuration file. And essentially, for your new contracts or a new version of contract, you'll simply increase the version number, and then you'll do a check within your migrate function to make sure that the version number is higher than the current version number. And it will make the migration from the old contract to the new contract. So essentially, you would execute a transaction um, that will state, I'm upgrading this particular contract to this new contract, um, and you will execute this migrate function within the new contract. If there's any like state changes that you need to do, you will execute those state changes or the logic for those state changes within the body of this migrate function. And that's it. So um, what this does, it allows you to upgrade your contract, fixing any bugs or any issues that might exist, which all bugs would be more than likely security issues. So it allows you to improve your code. It allows you to add new features, which is essential for any DApp really. If it's something that you will have for the long term, as users would want to interact with new features, new integrations, and allowing for your contracts to migrate to a new contract or upgrade your contract is essential, and that's core within the Archway ecosystem. All right. So another issue that I've seen a lot, especially with new developers, is they love to utilize the unwrap function uh, to to accept a value in a variable. So, for example, if you call a function and that function has a tuple, or there's an option where there can be a value or none, the unwrap will pass the value to your variable. But there's a big problem using this unwrap function, and the main problem is that if the value returned is none, there's a high chance that the entire transaction or execution will fail, and it will fail with a panic, which will cause some unexpected issues. So it's definitely better to deal with um, such actions using proper error handling as opposed to using an easy solution like unwrap. I understand that, like within Rust, having to deal with these options, usually you'd use a switch or some conditional checks to make sure that, hey, if there's a value, add the value to the variable. If not, then you can execute some action to deal with the non-value, and that requires a lot more work. I understand why a lot of users, especially new developers, decide to utilize the unwrap function, because it just removes all of that excess work into a simple solution. But there are a lot of drawbacks, and it's best not to use the unwrap function. So there are a few alternatives to the unwrap, and let's go through a few of these. So using the question sign operator, what it does at the end of any function call, it checks to see if there is a value or not, and then if there is no value or if there is an error, then it returns or propagates that error back to the calling function, and then you can now deal with that error in a safe way without it generating a panic and crashing the the app or the transaction. So this is one of the most popular solutions. So it simply allows for propagating the error back to the calling function. So it removes that issue where you might have a panic. So you can gracefully handle all the errors that might come about due to you making this particular function call. So this to me is the number one recommended solution. You also have the unwrap or unwrap or else functions. And essentially what it's trying to do is to set a default value in case there is a non-value. So this prevents having that panic situation. So in all cases, you will have a value, but yeah, you will determine what that default value is. And another, I think this is the final solution, is just going through with the match statement. And this is a bit more complex, but it gives you a lot more control in terms of what you can do. So usually you match the particular type. If there is a value, you can do some additional work there. If there is no value, then you can also set the original type to, or the value to the variable to none, or you can do some additional work there as well. But this really gives you a lot more control. And these are the preferred solutions as opposed to utilizing uh, that unwrap function. So I can't say this enough. It's best not to use that unwrap function, even though it's easy to use. You can definitely use it if you're in your test cases. That's not a problem. But when it comes to the production code, definitely not a good idea. All right. So this has been, I've seen this being an issue for a few contracts where developers, instead of using the CWS Store which plus package and the features that it provides, um, developers are actually storing data as vectors. It can work if the data is like a constant value, like it's only store one value. But if you're storing like a large vector, then as the vector or as the data increases, the performance of your DApp decreases, and it also increases the transaction costs. So yeah, we know that Rust is very good in terms of memory management, but one thing with vectors is that once the application or the DApp has to interact with that vector, it has to load the entire vector in memory and not just a subset or just the actual record that you need. It has to load everything in memory. So when you start out like with a vector with 10 records, um, that's not a lot. But if you go into when you start getting to thousands, hundreds of thousands, and millions, you'll see that everything starts moving at snail space. So because of this full data loading effect, uh, it does have a number of issues. So it increases the cost of gas as your data increases or your data set increases. Your DApp becomes less scalable, and then it increases the execution time. So users have to wait a long time. So this happens whether you're executing a query or if you're executing a transaction. And if like in that particular transaction, you're just querying data within that vector, you'll see that effect in terms of reduce or increase execution time or reduce performance because the data has to be stored in memory. And remember that memory is not infinite. So as the date, it might you might see for a particular the validator that this transaction is executing on, um, if they're running low on memory, you might that might crash. So this is definitely not a recommended solution if you're going to be storing a large amount of data over time. So let's look at this example. For example, so if you're creating a smart contract that manages an election, and um, each and the election has the voter details stored, and the DApp has a voter details stored in a vector. So every time you cast a vote or query um, the DApp, the entire voter vector gets loaded in memory. If you look through this example quickly, you'll see that once you call this get voters function, which is here, this now has to load and this voters variable from our data store from storage, and all of this data is then pulled into this bytes variable. So this is not a problem if there are 10 voters, but once you get into the millions, then you'll see all of this getting to be very problematic. So the main solution here is to always use this CW storage plus um, package or solution. And for basic variables, you definitely use the item type. And this is if you're storing like the basic values. But for more complex values, like what we saw in the voters example, you'd create this as a map. So this allows for creating various key valued pairs. So in a case, if you tie an ID or unique ID to a voter, so it could be a social security number, it could be an address, that would be the key. So if you want to load that particular record or check to see if a particular voter is already in the database, you'll just check. It will just make a check and load that one record if it exists. If not, it will return none, and then you'll know that, hey, all right, I need to add this voter to the record, or you can check to see if that particular voter has voted already. If not, then you allow them to vote. If they voted, then so the processing time is reduced a lot, because not all records within this map are loaded. So just that specific record that you need, that's the only record that gets pulled in to your DAP at that particular time, or into your code at that particular time. So it's way more efficient, and your gas costs goes down, processing time goes down, the transaction time goes down, and there is even more complex solution like the index map that allows you to do a lot more indexing, so you can do more even faster searching for large data sets. So yeah, just to reiterate, from the solution, you store, for the particular example that we showed, you store the voters as a map where each voter's address is the key, or the contract address, not contract address, their account address is the key. This allows for direct access to the voter data without needing to iterate over the entire data set. So you have access to the exact record that you need access to, and you don't need to go through every single record, which is more efficient. And and this works for querying as well. So it works both for executing transactions if you need to query data, and also if you're just doing a basic query. All right, so let's look at another use case, storing hard-coded data. And this can come up for a number of reasons, and I've seen it in the creation of NFT collections mainly. So if you want to have like a secure processing, you don't want anyone to know what is the state of a particular collection or the various assets within that particular collection. You want to load all the NFTs with the creation of the instantiation of the contract. So the reason for doing this includes prevent tampering. You have fast access to the data because everything is stored within the code, and there is a reduced computation load as well, because you don't need to depend on external third-party services or other chains. So one big issue with storing or hard coding data is that you have to understand that there is always a limit to how much data that can be stored on chain, and this goes for a contract as well. I think for Ethereum it's just like 20 something kilobytes, but for Archway I think it's about 800 kilobytes that you can store. Your WASM file size can be up to 8, so it's 819,200 bytes, so that's about 819 kilobytes. So that's the maximum WASM size, and it might sound large, but I've had cases where developers have asked us to increase the size of the max size that can be stored online, because they have a particular solution that is above this maximum. So yeah, there's a limit, and that's one big concern when you're trying to store or hard code a lot of data within your contract. All right, so let's look at an NFT example. So an NFT where the contract needs to hide private data in the WASM file for randomizing metadata of NFT reveals. So we've gone through, and I've actually seen this happen where a team went through this particular process because they wanted to do this exact same thing, randomize metadata for NFT reveals. And when they did the tests initially, with a few hundred NFTs, there was no issue. But once they started to increase the collection size up to say 3,000, then you realize that hey, we weren't able to execute or to store this particular contract on chain. And even though when you're storing contracts on chain, they are compressed, um, once they go on chain, they're extracted, and therefore the full size is determined. So if it's still above that max size, then it will not allow you to be the contract to be stored. So some possible solutions you could, for this NFT part example, you could create some encoding scheme to compress the data or the metadata. You could also store a lot of the metadata on external um, services. And also you could do the randomization process for the reveal off chain as well. So yeah, there are other avenues. It just depends on the particular use case. But once you understand that there's always a limitation in terms of storage space, then you'll know when you can use a particular option over the other. Okay, so another issue that I've seen is where there developers try to use a lot of what they've learned within the Web 2 space in Web 3. So, for example, this I've seen where um, adapt tried a developer tried to implement the microservice architecture within their solution. So each core component they would strip out as a separate contract and then try to connect those contracts. We're using various contract calls. So even the most basic contract call, you have this parent, our main contract that will then delegate or execute a call to one of the other contracts in order to execute a particular action. So each entry point might connect to a separate contract, and it might look good on paper when you're doing a lot of these modularized solutions. Might be easier to code or maintain over time, but what we've seen is that this over engineering within the CosmWasm space or smart contract space increases the transaction fees a lot, and it increases the processing time a lot as well, because each contract call is a separate message being executed on chain. So there's a lot of processing going on. That's one. And then there is another contract being executed, or contract call being executed. So the transaction fees will go up as well. So unless it's very necessary, I really don't recommend you taking that route to make to try to decouple or to modularize your contracts, even though it might seem like the best way to implement a solution. It might not work within the Web3 space. It might work within the Web2 space because you have a lot more resources at hand, so you can have um, a lot of servers working in tandem. Um, so you have a lot more working power and stuff. But within the smart contract space, it's just not the best way to implement your contracts. So it's best to like put as much of the functionality in one contract, and if there's a need to um, strip out a particular component that it can be reused, then yeah, that's a good use case for doing that. But don't try to over engineer it and try to do that for all actions. So one thing, like especially when you're interacting with contracts that you have no control over, that's even worse, because especially on Archway where contracts can implement their own contract premiums, you can, if you're connecting to 10 or more contracts in each contract call, and each of those 10 contracts have a premium. And the thing is, those contracts can also make other contract calls. So it can go on and on and on in terms of the list of um, contract calls that can be executed. And the problem is, if each of those contracts have premiums assigned, then that's an additional cost to the user. But separate from that, because you're making these additional contract calls, each of those contract calls will increase the gas that's required to executing the contract. So the final cost of the transaction will go up. So yeah, you just have to be very careful when you're trying, when you're over engineering for smart contracts. So my solution for this is always keep it simple. When it comes to smart contracts and gas efficiency and processing time, it's best to keep your contracts as simple as possible. Keep the logic as much as possible in one contract. Um, there's no there's no hard cap in terms of saying, hey, it must be, but I'm just saying, like, to reduce this problem of high gas fees and increase processing time, um, it's best to try to keep the logic in one contract as best as possible. But it's practical that, like, as your contract or your DApp grows in terms of the feature set and stuff, it might make sense to separate the contract. But as I said, if it's possible to separate the logic based on it being reused for other services as well, and being reused for multiple areas within your own contract, then it makes sense to separate that logic into separate contracts. But don't just do it because you feel like it should be done. Like, there should be a good reason for doing it. Okay, so let's look at storing data on chain. So this is one of the main benefits of creating contracts on Archway, is that you can store a large amount of data on chain. And but there's always good reasons to do so and not so good reasons. So, like for NFTs, and this is done a lot in NFTs, and there's a particular NFT template where you can store all your NFT metadata on chain if you wish. But once the data set gets too large, maybe it's wiser to store that data on separate solutions or services. So for IPFS is a popular solution for that. So usually you can store all the data on IPFS and then store the CID within your contract data store, and then you can fetch that from your front end. You can use that CID on the front end and fetch the entire data set or metadata from the IPFS storage. So that is how it's done, for example, on Ethereum at all times, because there's not a lot of data that you can actually store on chain within your Ethereum contracts. But there is always a good use case for storing on chain on Archway and utilizing IPFS. So, for example, I've seen an example where a particular DApp, they're allowing users to create articles on various posts, and they wanted to store, or they are storing a lot of this data on chain, so including the HTML content and everything. So with that, even though it is possible and you can do it, you're actually utilizing the Archway blockchain more as a database, as opposed to just a mechanism for executing transactions, basic transactions that you can then verify through other sources. So, for example, I think this particular example would be very useful utilizing IPFS or Jackal or one of those other storage mediums, as opposed to storing the entire content on chain, because it's very costly. So, I don't know the exact max data that you can store uh, within your the contract state. But the more data you store, you have to interact with within your contract, the higher the processing, and therefore the higher the transaction fee. So if you want to make it cheaper for your users to interact with your DApp, then it's best to have a large data set stored off chain. So once you start storing a lot of data on chain, then you'll see this problem where transaction fees and processing time goes up dramatically. And just for this particular example, we've seen that if you're storing HTML on chain, it can also increase the chance of cross-site scripting issues or vulnerabilities within your front-end app, because you definitely have to sanitize that data before you display it on your website, especially if you're interacting with anything JavaScript related. So if you're storing JavaScript-based content on chain as well. So usually if you're building a Web2 application, all of this will be taken care of for you within your database solution or your backend solution. But it's a bit difficult to do within a smart contract system. So a lot of these stuff, it's best to try to have the separation between what should be more the Web3 design framework, as opposed to and then utilizing external solutions to do what you normally do on the Web2 side. So as I said before, once you have a large data set, it's best to use some decentralized storage solution like IPFS. Jackal is a new player that you can utilize as well. And then what you do, you'd store just the hash of that particular record on chain. And then when the front end is interacting with that data, it will use the hash to then pull the full data set from the decentralized storage solution. So yes, that is what I have for you guys today. Definitely, if you have any questions, you can ask, put them in the chat or ask now. But we do have sessions on the Archway Discord that allows you to ask any questions. If you're having any issues building your DApp, we're there to help as best as possible. And also, like, if you need to like put together a team, like if you're working on DApp, you might be focused on the front end side, where you're looking for somebody that could help out on the back end side or the smart contract side. We definitely have channels on Discord and Telegram that can help you to find persons to join the team as well. So yeah, I hope that was helpful. And if you have any questions, please share.
Thanks a lot for that, Adrian. Looks like we do not have any questions for now. But definitely, we've dropped the link for Discord, Archway Discord in the chat. So if anyone wants to hop on, find a teammate, share some ideas, or just interact with the team and the builders over there, feel free to hop on over there. And for the office hours as well, if you have any questions from that you are building for the hackathon, anything, feel free to just take some time and hop on there. We also have a Archway Builders chat link in the details section of the hackathon page itself. That is a Telegram link wherein all the Archway builders are present. So feel free to check out that as well. But thanks a lot, Adrian, for wrapping off the workshop series for the hackathon. Like I said, we only have close to 9 days left, and we've already seen a lot of projects flowing in. And I wish all the hackers building in the hackathon a very good luck. Any closing thoughts that you have for the builders, Adrian, before we wrap this off?
Thanks, Mishka. So yeah, I was just told that we might have an extension to the hackathon by I think 2 weeks. So that will give developers some time to get their solutions submitted. So I'm hoping that you all will make use of these office hours and sessions on Discord and like ask anything. I know that it's very difficult building software solutions, especially within the Web3 space, smart contracts. There's not a lot of information available. There are a lot of examples out there. So it's a bit difficult if you're coming from the Web2 space. So yeah, definitely ask as much questions as possible. We're just here to help. So we're really looking for awesome submissions. So we're trying to help as best as possible. So yeah, looking forward to seeing you guys on Discord.
Thanks a lot, Adrian. With that, as Adrian mentioned, there might be an extension for 2 weeks of the hackathon submission deadline. But we will update it soon on the hackathon page, so you can also keep an eye over there. But extra time doesn't hurt anyone. And definitely, we've had a long technical workshop series, so that will give you some time to absorb all of it. Yeah. Best of luck, everyone. Thank you, Adrian. Bye bye.